This year, 2024, advancements in AI robotics have been incredible. Robot dogs are mastering parkour. With generative AI, humanoid bots like Digit are revolutionizing logistics, and surgical robots are performing tasks with human-like precision. We've got AI lifeguards saving lives 24/7, chemistry bots conducting hundreds of experiments autonomously, and even a robot created portrait of Alan Turing selling for over $1 million, plus NVIDIA's Jet and Tor platform set to supercharge the next generation of humanoid robots. It's a year of mind-blowing breakthroughs, so let's talk about it. First up, let's talk about robot dogs and generative AI. Teaching robots to adapt to new environments has always been a headache. You could use real-world data, but gathering that is super expensive and time-consuming. Digital simulations sounds like a great alternative, but they don't always translate to real-world success. Enter Lucid Sim, a groundbreaking system developed by MIT researchers. Lucid Sim uses generative AI combined with a physics simulator to create ultra-realistic virtual training environments. These environments mimic real-world conditions like lighting, weather, and even the textures of objects. Think about it. AI models describing settings as detailed as an ancient alley, lined with tea houses, or a sunlit lawn with dry patches. Lucid Sim takes these descriptions and maps them out into 3D training grounds, teaching robots to navigate tricky obstacles. The result is stunning as a four-legged robot trained on Lucid Sim nailed tasks like climbing stairs and locating objects in one test. It found a traffic cone with a 100% success rate compared to just 70% for traditional simulations, and MIT plans to use this system for more ambitious goals like training humanoid robots. So, eventually, robots will be handling tasks in cafes or factories with the precision of a well-trained barista. Sound crazy, right? Well, researchers are already working on it. Now let's move from the streets to the operating room at Johns Hopkins University. Researchers have trained the Da Vinci surgical system robots using imitation learning, a method where robots learn by observing human demonstrations. Hundreds of videos from real surgeries were used to teach the robot three critical tasks: stitching, lifting tissue, and using a needle. What sets this apart is that the robot doesn't rely on manual coding for every move, a process that can take years for complex procedures. Instead, it analyzes patterns from the videos to replicate techniques and even adapt in real time. For instance, if it drops a needle, it picks it back up and continues, a feature that wasn't explicitly programmed but learned through observation. The results are impressive. The robot matched human performance across tasks and showed consistent precision, reducing the risks of error. This approach eliminates the need for time-consuming programming, making it scalable for more surgical procedures. The researchers aim to take this further by enabling robots to perform full surgeries autonomously. In the future, this breakthrough not only improves accuracy, but also has the potential to address shortages of skilled surgeons globally, offering high quality of surgical care even in remote locations. Speaking of human-like robots, let me introduce you to Digit, the humanoid robot from Agility Robotics. This teal-colored bot stands 5'9" tall, weighs 72 kg with its legs backward, which is made intentionally. Digit is designed for logistics and manufacturing, tackling tasks like moving boxes in warehouses. One of Digit's standout features is its versatility. Unlike traditional robots that rely on wheels, Digit uses feet to navigate. This means it can climb stairs, walk across uneven surfaces, and move in spaces where wheeled robots would struggle to make it. Even more adaptable, its arms can be swapped out for different tasks, whether it's boxes in a warehouse or handling delicate items. This flexibility has already attracted big names like GXO Logistics and the Schaeffler Group, who are deploying fleets of digits to handle repetitive, physically demanding tasks. Here's something even more fascinating. Digits doesn't rely on verbal commands, especially in noisy factory environments. Instead, it takes instruction via an iPad, showing just how much thought has gone into its usability. And while its current charge-to-work ratio is 414 minutes of work for every minute of charging, the company is targeting 10-to-1 ratio soon. That could be a game changer, allowing digits to work longer shifts without frequent breaks. Thanks to large language models (LLMs) powering its AI, digits can adapt to new tasks and environments more efficiently over time. Now, let's switch gears to something life-saving. AI-powered robot lifeguards. In Liu City, Henan Province, China, researchers from the Institute of Physical Sciences have developed an autonomous robot lifeguard designed to operate 24/7 without human intervention. This robot utilizes artificial intelligence, big data, and navigation technologies to monitor designated water areas continuously. Equipped with a life-saving buoy and a rescue arm, it can detect drowning incidents and respond swiftly, potentially within critical time frames. Similarly, in Santa Barbara, California, the University of California's Benioff Ocean Science Laboratory has introduced shark guide AI drones that patrol coastal waters to detect and monitor shark activity. These drones captured real-time footage analyzed by machine learning models to identify shark presence, providing timely alerts to lifeguards and beachgoers, thereby enhancing safety measures. These developments highlight the growing role of AI in augmenting traditional lifeguard rapid response capabilities and continuous monitoring to improve water safety. Let's talk about a groundbreaking moment in the art world. An AI robot named Ida recently made history by selling a painting for over $1 million at Sotheby's. The artwork, a portrait of Alan Turing, the father of modern computing, fetched an astonishing $1,084,800, far exceeding its pre-sale estimate of $120,000 to $180,000. This November 2024 sale marked the first time a humanoid robot creation was auctioned, signaling a major milestone in the growing fusion of AI technology and the global art market. Another significant event occurred in 2018 when Christie's auctioned portrait of Edmond de Bellamy, AI-generated artwork by the Paris-based collective Obvious. The piece sold for $432,500, vastly exceeding its initial estimate of $7,000 to $10,000. This sale brought attention to AI's potential in art creation and its market value. These instances underscores a broader trend where AI-generated art is gaining recognition and commanding high prices in the art market. The success of such artworks raises questions about creativity, authorship, and the evolving role of technology in artistic expression. If you think robots are confined to logistics or art, think again. At the University of Liverpool, researchers have developed a pair of robots that autonomously perform and analyze chemical reactions. These robots are equipped with advanced AI-driven decision-making capabilities, making them more like lab assistants that never need a coffee break. They handle the nitty-gritty tasks of chemical synthesis, product analysis, and even planning next steps experiments without human interventions. Here's how they work. The robots are equipped with tools like nuclear magnetic resonance (NMR) and ultra-performance liquid chromatography mass spectrometry (UPLC-MS). This combo allows them to cross-check chemical data for accuracy, avoiding the false positives and negatives that can slow down research. For example, they recently synthesized a library of thioureas, analyzed the results, and autonomously decided whether to replicate, scale up, or tweak the experiments. The robots even use AI algorithms to adapt to unexpected outcomes, making decisions almost as intuitively as a human researcher would, except that they don't sleep. Over just a few days, these bots performed hundreds of experiments that would take a team of humans weeks to complete, and they are not limited to simple tasks. With modular tools and robust algorithms, they can tackle complex multi-step reactions. Even in fields like supermolecular chemistry, the implications are massive. These robots could revolutionize drug discovery, material science, and chemical manufacturing by dramatically cutting down costs and timelines. Right now, NVIDIA is stepping up its robotics game with Jetson Thor, a powerful computing platform launching in early 2025. Built specifically for robotics, it's designed to fuel the next generation of humanoid robots, enabling them to interact autonomously with humans and adapt to their environments with intelligence. Jetson Thor is the latest in NVIDIA's Jetson lineup, known for its compact AI computing platforms. While earlier versions were used in drones and IoT devices, Thor focuses exclusively on robotics. It leverages advancements in computer vision, natural language processing, and machine learning, allowing robots to see and learn from experiences and respond to complex situations. This means robots won't just execute pre-programmed tasks, they will adapt dynamically, like collaborating in workplaces or assisting with caregiving. NVIDIA isn't building robots themselves, but is partnering with manufacturers like Tesla, Siemens, and Universal Robots. For instance, Tesla's humanoid robot relies on NVIDIA's tech with limited production plan for late 2025. While challenges like sensor technology and ethical considerations remain, NVIDIA's VP of Robotics, Deepu Talla, acknowledges this is a long-term journey. Let me know what you think in the comment section below, and if you enjoyed this, make sure to like and subscribe for more updates like this. See you in the next video.
For more on well-researched and balanced stories, events and interviews across business, tech innovation and lifestyle, please like, share and subscribe to this channel, www.youtube.com/digivationnetwork.